to all. I am Professor Devendra Singh, taking this course on a machine design, and this is our third lecture and module 1, that is related to introduction in machine design. Until now we have discussed about the basic definitions related to machine design. We have started in fact from engineering design, what is engineering, engineering क्या है, engineering design क्या है, and then we have moved to mechanical engineering design, machine design, and various related related definitions like empirical design, rational and combined design, etc., etc. Then we have also covered the design cycle, design procedure. We have also discussed in last lecture about the BIS designations of steels, plain carbon steel and the alloy steel. Now, we have moved to the lecture 3. There in this lecture, we will discuss for the selection of preferred sizes. What is the utility of selection of preferred sizes? We can think, if we design something, अगर हम कुछ अपना डिज़ाइन करते हैं, so that design must be fulfill the demand of the maximum population in the area. हमारी ज़्यादा से ज़्यादा जितने उसके कंज्यूमर हैं उस एरिया में, उस जिस सिटी, स्टेट और कंट्री और ओवर द ग्लोब व्हाटएवर, उसको हम मिनिमम नंबर ऑफ मॉडल्स के साथ फुलफ़िल कर सकें. सो कुछ एक ऐसा सिद्धांत हमारे सामने आया जिससे हम उसकी कैपेसिटीज़ या साइज़ इज जनरल टर्म, कैपेसिटी वह इस वेरियस स्पीड्स हो सकती हैं, डायमेंशंस हो सकती हैं, जिनको हम डिसाइड करके और लोगों की नीड फुलफ़िल कर पाएँ. सो प्राइमरली दिस लेक्चर इज़ डेडिकेटेड टू selection of preferred sizes, and then we will try to start the introduction to engineering materials and the basic criteria for selection of materials for design of a machine component or machine element. So, the overview I have discussed, and the outline of this lecture is, as I have discussed. First, we will discuss about the introduction of selection of preferred sizes. Preferred size is a general term. This is a general term. It may be capacity, it may be the size means the dimension, it may be speed or any other parameter we can consider as sizes. And after discussion of the basic series given by the Charles Renard, we will come to the derived series. There are some series we have derived from the basic series are termed as the derived series. Then we will definitely like to have a discussion over the advantages of selection of preferred sizes. Then we will try to attempt 2 numericals on the selection of preferred sizes, and then we will try to touch the basic criteria for selection of materials. So, this is the outline of this lecture. So, first of all, what is preferred size? This is a philosophy given by Charles Renard. He suggested to generate a sequence or generate a table of various sizes which are related or which are in the geometric progression fashion, and he has suggested some basic series. So, 5 basic series are there which had been suggested by Charles Renard. He is a French balloonist, and these basic series are R 5, R 10, R 20, R 40 and R 80. These are the 5 basic series suggested by Charles Renard, and on the basis of these 5 series we can build up a series of the sizes which should be designed or which should be produced to fulfill the requirement of that population of that area. And for each basic series, हर basic series के लिए एक series factor fix है, and there is a very simple thing 5, 10, 20, 40, 80 जो 5, 10, 20, 40, 80 आर के सामने लिखे हैं उतना 10 का वो वाला रूट उसका सीरीज फैक्टर बन जाता है. सो वी कैन रिमेंबर द फिफ्थ रूट ऑफ 10 is the series factor for R5 series, 10th root of 10 is the series factor of R10, 20th root of 10 is the series factor for R20, and 40th root of 10 is the series factor for R40, and 40th 80th root of 10 this is the series factor for R80, and these are the values of these roots. So, for R5 we use 1.58, and for R10 this is 1.26, for R20 this is 1.12, R40 this is 1.06, and R80 is 1.03. In fact, there is these are the fixed ratios, these are the fixed series factors recommended by Charles Renard to build a series. Now, the sorter the derived series, sometimes the number of products and number sizes are more. So, we need to sorter the series. For that we have to eliminate some periodic elements from the basic series, and the resulting series are called the derived series. And there is a standard nomenclature to denote the derived series. Derived series को लिखने का उनको बताने का एक स्टैंडर्ड नोमेनक्लेचर है, उस नोमेनक्लेचर को हम समझ लेते हैं. सो डेजिग्नेशन फर्स्ट कॉलम में लिखते हैं और डिस्क्रिप्शन के उसका मतलब क्या है दैट वी विल राइट ऑन द डिस्क्रिप ऑन इन द सेकंड कॉलम. तो फर्स्ट दिस इज R5/2 that is 1 to 2000. This is lower bound and this is upper bound. So, both are inclusive in this, and this 5/2. So, 5 R5 is the basic series, and /2 means every second term will be eliminated. This is the way you will the basic series you will consider to get the derived series is the R5, and every second or every alternate term will be eliminated. And in this derived series 1 and 2000, these are both ends are fixed, both ends are closed, these are inclusive. So, this is the meaning of comprising every second term of R5 basic series, including 1 and 2000 as lower and upper bound. Similarly, you can have R10/3, R10 basic series, from which you will derive this R10/3, and 3 indicates every third term you will eliminate, and 50 means this must be there in this derived series. So, the meaning इसका मतलब होगा कि बेसिक सीरीज़ R10 जो हमने डिज़ाइन किया है उसका हर तीसरी टर्म एलिमिनेट किए है और 50 इंक्लूडेड है. 50 अगर थर्ड टर्म आती है तो वी विल नॉट eliminate it, we will consider it in the derived series. Then R20/4 meaning is same. R20 is the basic series and every fourth term will be eliminated. 1 is the lower bound and upper bound is open. So, it is infinite series, it will start from 1, and this is the comprising every fourth term of R20 basic series, including 1 as first term and open upper bound of the series. So, R40/5. So, R40/5 means R40 is the basic series and every fifth term will be considered here, and it is upper bound 300 is fixed. So, it is lower bound is unbound, this is free open, and the upper bound 300 तक जाके ये कंप्लीट हो जाएगा और हर पाँचवीं टर्म यहाँ पे लेंगे हम कंसिडरेशन में, यहाँ पे हर तीसरी टर्म कंसिडरेशन में लेंगे, यहाँ पे हर दूसरी टर्म कंसिडरेशन में लेंगे. सो this is the meaning. So, we will eliminate few terms and we will get the sorter. So, this slash or the figure below the slash will indicate which term you are going to select for the derived series. So, always remember. So, comprising every fifth term of R40 basic series, including 300 as upper bound and lower bound is open. So, lower bound in this derived series is open. Now, what are the advantages? Then the most important advantage in my opinion is because whenever you start any business, so we must know how many products and how many models we should produce. So, that our business should give the profit to survive. So, there must be some logic to decide the sizes. So, this is one philosophy which provide or which helps the designer to select the sizes of the products for any business or for any production unit. So, this is the most or in other way I can say ki it helps to designer to avoid to take the arbitrary decision to select the sizes of the product whatever he is going to design. So, now we will uh, see the first uh, advantage. The difference in two successive terms has a fixed percentage, because for every series there is a fixed series factor. For R 5 it is 1.58, for R 10 this is 1.26, R 20 it is 1.12 and so on. So, in any series, in any series which we are considering, अगर किसी भी सीरीज को लिया है तो उसमें एक फिक्स परसेंटेज का गैप मिलेगा. और दूसरा, if the quantities are small, sizes are small, then we are getting the small steps to fulfill the requirement, and if the quantities and the sizes are larger, then the larger steps and the series we will get. So, this is as per the universal law. So, this is in support of the universal law. It supported by universal law. For the variation, the product range is covered with minimum number of sizes without restricting the choices of the customer. Here we should always remember, मैं यहाँ एक चीज़ ये कहना चाहता हूँ और यहाँ पे हमें ये याद रखना चाहिए कि starting of any business, we should always, whether it is mentioned or not, we should always consider the R 5 series to decide the sizes of the product whatever it is. So, that we will start with the minimum number of R 5 is the basic series which will give you the minimum number of the sizes to fulfill the requirement of the or fulfill the demand. So, this is an important point we should always remember whenever we are using this. The preferred sizes assist the designer to avoid the selection of sizes in arbitrary manner. That is the most important advantage of the selection of preferred sizes in my opinion. So, these are the advantages, and now we try to look what is the meaning of the selection of preferred sizes and how we should move to the how we should attempt the numerical problems. So, here again this is having a background of the geometric progression, but it should not be attempted in that manner. So, if something is given and you will start attempting the problem like a algebra problem for geometric progression, first term is known and the last term is known, and you need to find out the 5 intermediate terms, total 7 terms in that geometric progression. So, this is not an algebra, there is some philosophy. We should always use R 5, R 10, R 20, R 40 and R 80 series, and if it is not, then if number of sizes are there, then we should always try to use the derived series by removing some terms and selecting appropriate one, as we have discussed the previous slide. So, this is our first problem where we try to understand what is it. So, it is required to standardize 11 speeds from 72 to 720 RPM for a machine tool specify the speeds. So, initial एक व्यक्ति इसे स्टार्ट करना चाहता है जिसको मैं मना कर रहा हूँ कि आप ऐसा ना करें कि हम कहते हैं कि A इज इक्वल्स टू 72, L is equals to 720, N is equals to how many? Here 11. So, you can find phi or you can find R. This is what? मालूम है हमें L is equals to A R raised to power n minus 1. This is geometric progression. You can get L and you will definitely get the 11 sizes between 70 to 720. So, what is the wrong with it? There is so this does not fulfill the philosophy given by the Charles Renard. So, there is no intimation given whether this is a first business or the second expansion or whatever. So, we should start with the R5 series. First trial we will use R5 series, means the series factor is 1.58 and the first speed I will think it should start with 72. ये 72 से स्टार्ट हो 720 तक हो और 11 मुझे मिल जाए उस फिलोसफी के साथ, that is the best solution. Or if it is not, then we should try to get the optimum solution. अगर कुछ हमारा किसी एन को हम फुलफिल नहीं कर पा रहे हैं, सपोज अपर एंड पे हाँ कुछ हमें छोड़ना पड़ रहा है तो दूसरे एंड पे कितना छोड़ना पड़ रहा है ये हमें देखना आवश्यक है कि ताकि मैक्सिमम पॉपुलेशन, वही एक फिलॉसफी है कि मैक्सिमम पॉपुलेशन इसका फ़ायदा उठा पाए, देन यू विल be successful in your design, otherwise it will be very difficult to survive. So, first speed I started with 72 RPM. Yes, you should always write units, RPMs. You should always write RPM, right. So, second speed I forget to write the unit. So, you should always remember, you should write the units without any failure. So, second size we have to build this geometric progression and the series factor is 1.58. So, this is 113.76 and final we will always give the nearest integer value, we should recommend, we should not give the fractional value, as we should not recommend for the sizes. So, this is 113.76. So, 114. Then third speed means this is our second speed multiplied by 1.58 again we will get 179.74, when this is 180. Fourth speed we will get similarly 283.99 and it is rounded off to the next integer 284 RPM. Fifth speed we are getting 449 with the same. Sixth speed this is 709. Seventh speed this is 1121. This is 1121 and our range is this. It means now I will decide कि R5 series is not suitable for me. I have to, मुझे अब इससे अगली सीरीज़ पे जाना पड़ेगा बिकॉज 7 स्पीड में 72 से स्टार्ट करके 7 स्पीड इसमें मैं फाइंड आउट नहीं कर पा रहा हूँ. सो आई हैव टू मूव टू द अनदर नेक्स्ट सीरीज दैट इज़ R10 for which the series factor is 1.26. So, I will move to the next series. Right. So, it is needed to move to the next series, that is R10 or R20. The series factor for R10 is 1.26 and for R20 is 1.12. हम इन दोनों को देखते हैं, जैसे हमें मालूम है L is equals to A R raised to power n minus 1. So, this is fixed 1.26 and 1.12. So, we can find out what is the last term if I start with the 72 RPM. तो 72 से अगर स्टार्ट करेंगे और रेशो फैक्टर ये और ये ले तो हम ये डिसाइड कर सकते हैं कि हमें किस पे जाना चाहिए. दिस यू कैन रिमेंबर. सो इफ़ आई कंसिडर दिस R10, so 72 is the first speed and this is 1.26 raised to power n minus 1, this is 726.96 1.16 RPM. इसको राउंड ऑफ करने का यहाँ मुझे डिसीजन लेना है. That I will take the decision here. And if I take the R20, so in R20 this series factor is 1.12 and 72 is the initial speed, then this is 223.62 RPM 7th स्पीड होगी. अगर पूरा डिस्ट्रीब्यूशन लिए लें, ये लोअर बाउंड ये अपर बाउंड, सो हम ये देख रहे हैं कि यहाँ पे अगर R20 लिए तो इतना कवर हो रहा है और इतना बाकी बच रहा है. सो दिस इज़ नॉट ए वाइज डिसीजन. अगर मैं R10 लेता हूँ तो ये पूरा कवर हो रहा है 72 से और ये थोड़ा सा ऊपर चला जा रहा है 726. सो आई विल स्किप दिस एंड आई विल मेक दिस 726.16 टू 720 RPM. इट मीन्स with R10 I can find out the 7 speeds between 72 to 720 using this R10 series. So, I have decided I will use the R10 series, for which the last size is this, and for this I will take 720 in place of this. So, now the calculation for that. First speed 72, second speed ratio factor I have changed, this is 1.26, so 90.72, so 91, and similarly we will get this is same. All 7 speeds we have covered. This is 288 so there is some error, right. 8th speed, yes, we need to find out the 11 speed, not 7. So, please so 10th speed and the 11th speed, this is 720 here. So, we have taken the 720 from 72 to 720, we have find out the sizes or the speeds which can be recommended for the satisfaction of the need of the person living in that area or in that continent, nation or state. Another problem here, this is a manufacturer is interested in starting a business with 6 different models of dumpers ranging from 10 to 100 किलोवाट. एक बिजनेसमैन है जो एक डंपर मैन्युफैक्चर करना चाहता है 10 से 100 किलोवाट के बीच में, और सबसे पहले वो बनाना चाहता है केवल 6. जब ये पॉपुलर हो जाएगा then he expands. So, specify the power of the models, and after popularization of the proper demand of this coming, then he expands expansion plan to further increase the number of models from 6 to 11. So, हमें ये देखना है. So, for that first we will start with this R5 series. For that series factor is 1.58, and first capacity we will start with 10, second capacity 10 multiplied by 1.58, this is 15.8 and rounded off 16. So, in this way we will get these 6 capacities 10 kilowatt. Again you should always remember units. So, 10, 16, 25, 39, 61, 97. So, lower upper bound पे 3 kilowatt का केवल gap रह गया. We can accept that, and these are the standard sizes. Now, to further increase the capacities in the required capacities, it is required to move to the next series R10, which has this series factor. So, we are using the same concept. First capacity 10 kilowatt से start किए, second capacity, third, fourth, fifth, सिक्स्थ, सेवन्थ, हमें 11 चाहिए. ये सब किलोवाट हमें रखना है, ध्यान देना है, यूनिट्स नहीं छोड़नी है. किलोवाट. And then the 8th capacity, this is 50.41 is 51 rounded off, 9th capacity is 64, and 10th capacity this is 80 and 11th capacity this is 100.85 that I have reduced to 100, and thus we have expanded from 6 to 11. So, from the first time 6 capacities are 10, 16, 10, 16, 25, 39, 61, 97. Now, expanded by using R 10. So, if I use expand capacities to manufacture, so 10 is there, it is there, 16 के बीच में 13 ऐड हो गया, 16 यहाँ पे है, 16 और 25 के बीच में 20 ऐड हो गया, 25 यहाँ पे, and similarly and you will get some capacities which are near to the earlier values, and in this way we have generated and we have taken the logical and mathematical supported decision to decide the dimension to fulfill the need of that population for which you are designing something. Now, the next engineering materials, any material which is having any engineering application is called the engineering materials, and as far as the classification is concerned. So, engineering materials are primarily classified in 3 categories: metals and alloys, then known metals and the composites. Metals are ferrous alloys and non-ferrous alloys. The basis is the iron, then the ferrous alloys like your steels is the ferrous alloy, that is carbon and iron. Non-ferrous alloy where basic there is no presence of the iron like aluminum alloy, copper alloy, gunmetal, etc. Brass, these are the known ferrous alloys. Known metals like wood, rubber, glass, asbestos, these are the known metals, and composites they are the combination of the two materials. In fact, there is a difference between alloy and the composite material. In alloy, the two materials we combine in the appropriate proportion, and they lose the component lose their properties and new property is there. In composites, the two or more no more materials are combined together, and the component materials do not lose their properties and enhanced mechanical properties we get in the composite. So, composites can be further classified in the particulate composite and reinforced composite. So, particulate composite we make by powder metallurgy, and reinforced composite is there is a matrix and reinforced matrix material, and the reinforcement material is there. So, composite materials I have discussed. Then the particulate composite, it is in particulate composite discrete particles of one material surrounded by a matrix of another material. This is manufactured by powdered metallurgical technique. Example of such composites are grinding wheels, welding electrodes, sintered carbides, etc. And the reinforced composite, you may take an example of RCC column. So, composite materials are made of a base material and a matrix like metal matrix, composite, glass fiber, reinforced composites, and carbon reinforced composites, etc. These are, and the basic criteria for the selection of material is the availability. The material must be available. If it is not available, there is no case of use of that material. For the design, the cost is cost included your manufacturing cost, raw cost, and transportation cost. Whatever you design, it should be economical and safe. Then the manufacturing consideration, whatever material you consider for your design, it should have the desired manufacturing ability to convert the raw material into final shape, and then the material properties in that material must be there to face or to face the conditions in the real time application. These are the basic criteria for selection of materials. So, we will continue with this discussion on basic criteria for selection of materials in the next lecture. So, for today's lecture, this is all. So, thank you very much.